Tires, those four black rubber things that nobody really pays too much attention to, have brought me to the city of Kolmerberg in Luxembourg. This is the home of Goodyear and their innovation center. Not only do they produce tires here, but more importantly, they're producing the tires of the future. We're going to find out what those look like. There is real chemistry in this show as we strip a tire down to its core ingredients. Uncover the fine-tuning and testing that goes into each and every tire produced, both in the laboratory and of course out in the real world. I get to fulfill a lifelong dream of lapping the Neuschleifer before heading to the south of France to Goodyear's test facility in Miraval, where I experience firsthand what it's like to be a tire tester. It'll change your attitude to tires. The Goodyear brand is synonymous with tires and is well known throughout the world, but like most global companies, they too had humble beginnings. In 1898, Frank Siebling opened a factory in Akron, Ohio in the US. Aided by his brother Charles, they managed to raise the capital needed of $13,500 to begin operations. Timing, as you can imagine, was critical as the nation was on the verge of a revolution, with the demand for bicycle and carriage tires, and of course a new type of horseless carriage that was bouncing into prominence. The fledgling company is named to honor Charles Goodyear, the discoverer of vulcanization. This process of adding sulfur to rubber meant that rubber no longer melted in summer or became brittle in winter. Operations shifted dramatically at the onset of World War II. Goodyear expanded and started producing the Vought Corsair fighter aircraft, over 3,000 of them, for the war effort. Another innovation was the development of airships or blimps for maritime patrol and observation. Incidentally, for Goodyear, they continue to operate these blimps as fantastic moving billboards and camera platforms to this day. When the USA entered the conflict, President Roosevelt offered refuge to the royal families, in particular the Grand Duchess Charlotte of Luxembourg. A friendship developed, and it was during this time that Goodyear and the Grand Duchess paths crossed. The result is that post-war in 1949, Goodyear began a phase of global expansion and built a factory in the town of Kolmerberg.
Goodyear first had the idea of setting operation here in Luxembourg. We started with a manufacturing plant, and 60 years ago, actually, we opened our innovation center. At the time, there was a need also to develop products for Goodyear here in Europe because the emergence of new customers and new opportunities, and therefore we also opened a research and development center here in Luxembourg.
You'll be forgiven for thinking there can't be much innovation and design in tires. After all, they're rubber, black and round, but you'd also be very wrong. It's not all about tires. I look on your walls, you've got a lot of inspiration from the environment, the world. Is that how the process starts from a design perspective for you?
Yes, so exactly, we need to start from something like a trend which we see rising. It can be based on architecture or based on product design, fashion that we are also looking at. Textures that we could find in animals, so everything which is bionic, coming from the nature is also a good inspiration. And we start from there and we do our first designs by hand sketches, because we think that you get more freedom, more sensibility in these hand drawings than starting completely from the computer. And you can see up to 40-50 modifications of our initial design up to the final production. And it might take two years to develop one tire.
How the tire and mobility solutions for the future could look was turned on its head when Goodyear first rolled out their Eagle 360 concept at Geneva in 2016.
The technology that you have seen in this Eagle 360 might come in a different shape in the close future. So I'm talking about, for example, sensors. So this Eagle 360 has a bionic skin which can sense if you are driving on dry road or wet road, and it will adapt depending on this road condition. It can be a slick on dry road, but it can enable dimples, grooves that would evacuate this water.
But the future is closer than you think.
And all this deformation that the tire gets during handling, during braking, acceleration, taking up potholes, this energy could be transformed into electricity with various materials. But also a tire gets up to 80 degrees inside while driving, so which means also a huge capacity of energy that could be in some way transformed into electricity.
So the challenge that we have for us and for all the development teams is come to with those new technologies that will give the solutions for the future. Okay, the tires that we develop today are the ones that are going to be in the market tomorrow, and we have to anticipate the consumer needs, but also to respond to those technological needs. And there is more and more requirements in terms of improving the performance at all ranges.
This is not a fashion accessory that matches my watch. The minute that I put these glasses on, we're getting down to serious work. I am a lab rat, and all these things you see set on a table here is not some exotic experiment to create something that's going to take over the world. This is what is that round black thing called a tire. These are all the ingredients that go into that wonderful recipe that makes a tire. Guy, you're looking very, very busy. Is this a dangerous experiment?
No, we are just
Making a tire.
A new compound for tire. So that's what we are experimenting. And as you can see, we have a lot of different things that we can put in such a mixture in this compound. And so it's chemistry. So we have.
1 second.
Yeah. Go ahead.
This is important. People think that a tire is just some rubber put in a mold, and there you go. But this is not the case. How many different materials, on average, go into a tire?
So in average, I would say we have about 20 different materials. So starting with polymers, so natural rubber, synthetic rubber. We have carbon black over here, so very important. Very important also today, the new tires include all silica, so as you can see it's very, very volatile. So coming out of sand somehow. And we have protective, so vaccines which protects our tires on the road, again the sun, again gasoline on the road. Further on, and most important at the whole end, is the sulfur, so that makes our compound pure. Okay. I will show you some thing on this.
So all of this comes together in some wizardry, some magic potion, and we end up with a tire.
Yes, that's it.
Wow.
Innovation is at the heart of all they do, and as you will see in the show, there are just so many stages in the development process of any new tire. Yet for me, it's here in the lab where it comes to life, where creativity and chemistry come together. This is, after all, the foundation of all tires.
Another small experiment on your way. You see here we have one compound which is highly loaded and one compound which is not highly loaded. So that's the difference between rolling resistance. You can imagine here we have a very good rolling resistance,
Yeah.
and you are the bad rolling resistance. And
Oh, jeez. I thought I had good hands. Just to check if that thing goes nowhere.
So just because they all look the same on the outside, black and round, doesn't mean they are. So once a new compound has been cured or vulcanized, the testing begins. The speed test is a test to extreme, to failure. Using a stroboscopic light, you can clearly see the deformation in the tire, that wave pattern on the sidewall. Now this is how tires are speed rated. Tires will also be subjected to endurance, durability and rolling resistance tests, and they also have machines which can simulate slip, braking and acceleration. But the testing doesn't stop. 24 hours a day, they have 3 shifts, and all this data is fed back into the system so that changes can be made to compound and design, and then the process starts again. The testing isn't just restricted to the laboratory. The relationship between tyre and car is obviously a critical one, and Goodyear works closely with manufacturers in developing and testing tyres on specific models. But there's another tyre performance test that wasn't as obvious, but one I found most interesting.
This is the noise lab that we're using, of course, and the first thing you see is that it's a typical noise isolation, except for the floor.
Okay.
And we've got one big advantage testing tyres, and that is that the tyre noise, of course, is created at ground level between where the tyre is contacting that road surface. And so for us, one big advantage is when we're making this measurement, because the noise is coming at ground level, it's going directly to the microphones. We don't have reflection off the floor. The tyre is nothing more than a drum. And if you hit the tyre, it will resonate like a drum. And of course, when we go to a rough surface like this, it's not the tread design anymore, but it's the whole structure of that tyre vibrating which is creating the noise. So two main aspects of noise then: the structure of the tyre vibrating coming from rough road surfaces, and a possible noise being created by the design of the tyre itself. Then it's very easy for us to find where the source is. We'll do a test on a car with our instruments, with our microphones in the car. We identify what is the frequency of the noise that we would like to remove, and we can see very clearly whether that frequency can be generated by the tread design or whether it's one of the structural frequencies coming from the vibration of the tyre.
If you think about that the tire is the only point of contact between the vehicle and the road, you can already have an appreciation of how demanded is that tire from a performance perspective. Now, that tire is also going to influence how the vehicle handles, how the vehicle grips, and all the characteristics of that vehicle interacting with the road.
But of course, tyres don't live in a laboratory, they live in the real world. And this is what this is, the actual evaluation centre here in Collenberg, where the tyres get put onto cars, driven by test drivers to evaluate them in real world environment. I'm going to get to experience that.
There are a lot of different kind of tests what we do for the development, and this is one part of it.
This is the one you like the most?
This one is the most interesting, yes.
So I see the corners are all very, very different. Some are very tight. This is to really test all the dynamic abilities of the tyre.
Yes, this test is foreseen to check how the tire is working. On heavy handling, if it's quite okay to drive, if you have a good response, and it's still easy to handle.
After the break, it's my turn behind the wheel on the greatest test track of them all, the Nordschleife, before visiting Goodyear's purpose-built test facility in the south of France. The Nürburgring is a motoring mecca, a hallowed ground filled with legend and bravado. Opened in 2009, the museum and theme park, like the circuit, have faced some challenging times, but a walk through the museum brings you face to face with legendary drivers and their iconic racing machines. There is a lot to see and do, a mix of interactive fun and games for the new generation. But like the track, it's the classic cars like Jackie Stewart's Cooper F3 that remain a standout for me. After all, it was Stewart who coined the nickname for the track, the Green Hell. Built as a showcase of German automotive engineering, construction started in 1925. The fact that it took them just 2 years to build the then 23.8 kilometer course, and it still stands here today, I think they've pretty much achieved what they set out to do.
But having driven here now, I really do appreciate why the Nürburgring, Nordschleife, the Green Hell, is so important for manufacturers. It's the ultimate test of machine, driver, and of course, tyre. a couple of laps here and you realize this is like driving on an everyday road. The surface is by no means perfect. There are bumps, there are dips, there's changing conditions. One side's dry, one side's wet. So for a company like Goodyear, testing at the Green Hill is critical, but nothing can prepare you for the elevation changes. You're talking a difference of 300 meters, which it is insane. I just spent my time on this track thinking, my goodness me, the Formula One drivers of old, what brave, courageous, fantastic drivers they were, because there is no runoff here. You make one little mistake, you are going to crash. You probably are going to die as well. And I guess that's why people like Jackie Stewart called it the Green Hill. It is a track like no other. It can never be built again. It is something that needs to be preserved, looked after, and if you have an interest in cars, make a pilgrimage. Make sure you get here so you can get to drive on this track. It is a real special experience. I think it's fair to say this hasn't been a good day. It's been a flippin' good year. From the Green Hill to the south of France, just outside Montpellier is a town called Miraval, where we have a test facility designed specifically for the testing of tyres. The track was built by French Formula One racing driver Jean-Pierre Beltoise in 1974. And this facility is state-of-the-art, world-class, and this is where Goodyear does all of the advanced tyre testing. Now, earlier in the show, before the ad break, I got to see what goes into testing tyres. The challenge for me now is to become a tyre tester. Now, just because you think you can drive a car doesn't mean you know how to test tyres. That is going to be a real challenge for me, who thinks he knows it all.
A tyre test can be split into two distinct parts, objective and subjective tests. Now, with all the data capturing equipment fitted to my Golf, it is clear that wet stopping is an objective test. Equipped with an automatic brake system, my job is pretty simple. Guide the car into the test area, get it up to 85 kilometers an hour by the time I trip the sensors, and the car will apply 100% brake force. Limiting steering inputs is critical, as this obviously can affect the stopping distance. This test is run 5 times, and the stopping distances can't have a variance of more than 1%, otherwise additional runs would need to be completed. The test is then repeated, but on a competitor brand.
So what happens when you're going through a corner and you suddenly hit a puddle of water? The car's going to behave in a funny way, isn't it? Well, that's what this test is. The challenge here for me as a driver is to be consistent in terms of speed and consistent in terms of steering input. No deviation from me. This is an objective test. And what we do is we go faster and faster and faster until eventually the lateral grip of the tyre gives. There's going to be a movement. So the challenge for me is not to correct, which is inherent in our heads, is just to be consistent on that speed. And obviously we'll see at which point the tyre is going to let go. We're going to run it on the Goodyears and then run it on a competitive tyre as well and be able to compare the results. It's going to be interesting.
The Miraval test facility is geared up to test all types of tyres, Goodyear's popular Wrangler tyre certainly earning its all-terrain credentials.
This just kind of blows your mind. It's 35 degrees in the south of France, and we're standing on a track that is just perfectly wet. This is something that sets Miraval apart from a testing facility for Goodyear. They have a 1.1 kilometer wet dynamic handling track. I haven't seen this anywhere else in the world, and this is going to be a real challenge for me. Cyril, tell me what you as a test driver have to test, and what are you looking for on the wet handling track?
Okay, so on the wet handling track, we check the balance of the car, if the traction is okay, if it's not dangerous for the customer, if braking is okay as well on the wet.
Now, I know a lot of the tests we've been doing today is very difficult because you have to be objective. You don't drive the car, you have to let the tires talk to you. This is a little bit different, it's subjective, so you need to drive the car and give the feedback.
Yeah, So the challenge when you do subjective tests is to forget to drive and focus on the tires and let the car drive and try to stay on tracks and if everything is okay, you can.
Now, we have data on board. Is it a lap time that you want to try and set going as quickly as possible?
Yeah.
How many laps do we do?
So we have to make some 3 laps or 5 laps depending the quality of tires and maybe sometimes you miss one brake point and the laps is not okay. Yeah. So we have to be closer in lap time, to be regular, to analyze the tires correctly.
And then obviously we're going to go out on Goodyears, but we'll also use a competitive tire so we can see the difference.
Yeah.
Very good, eh?
So you know what?
I didn't touch brake. Well, that wasn't the greatest start now, was it? I pretty quickly learned that clipping the curbs wasn't a good idea. It's very consistent, front and back. So I find it quite easy to balance with just accelerator without having to brake too much. But most customers are going to come on the accelerator like this, and then you can feel it just loses that grip. But the rear doesn't slip. After our laps on the Goodyears, it was back to the track, but this time on a competitor tyre. Something doesn't feel right. There's a shift here when you go in here. There, already I'm sliding.
Yeah, you slide. Yeah.
Already.
Yeah. Inside, in entrance. Yeah.
At the end of the test, Cyril and I completed the comprehensive report, giving our input and scores.
Change of the lane. And when you come back.
I'll do one more,
Yeah. Perfect.
On the test track, lane changes and how the tyre responds can obviously be tested dynamically before we head out to the circuit to complete a few laps. Now, where the normal on-road test we saw earlier would see you judging tyre noise and comfort, on track it is dynamic and extreme. What we're testing for here is things like rear stability in high-speed corners, the level of front-end grip and turn-in, and of course how the tyre responds under harsh braking and acceleration. But what we're also looking at over the duration of the laps is how does the tyre performance drop off.
The brake seems still okay, no?
I'm not as good as you. But all of this, no brakes.
No.
You just don't end a show better than this, do you? A hot lap in the GT4 around Miraval. Our test driver, Joel, has been doing this job, testing tyres at Miraval for 35 years, so fair to say he knows his way around the circuit. But you know what amazes me? The job that I do exposes me to cars all the time. We're test driving them, so I understand just how advanced tyre technology is. Yet after this trip, I am further blown away by the commitment to design, the hours and hours spent in laboratories, not only preparing the compounds, but also testing the tyres, and then hours spent on test tracks, like in Kolmerberg and here at Miraval. Why? To ensure that what goes into the tyre is going to make it more efficient, is going to improve the performance, more importantly, is going to make it safer and more reliable for you. That's me, who's in the industry. It just blows me away that people still think you, the driver at home,
that those just 4 little pieces of rubber that happen to come with the car you bought.